Bismillah ar-Rahman ar-Rahim. Last lecture, we started the properties of number systems, okay? And we said, let me just summarize the properties very quickly. So we said that the largest integer of n digits in base R is equal to R to the n minus 1 if you convert it to decimal. And the largest fraction of m digits in base R is equal to 1 minus R to the minus m if you convert it to decimal. If you combine the two, you get R to the n minus R to the m, which is the minus R to the minus m, which is basically the largest number that you can represent in base R with n integer digits and m fractional digits. Okay. And the result of adding 1 to the maximum number, okay, to the maximum integer of n digits is going to be 1 followed by n zeros in base R, okay? How many integers are there using n digits in base R? We just proved that this is equal to R to the n, okay? Today we are going to learn about two more properties, okay, simple properties, okay? So given an integer, a positive integer, let's say, a positive integer z, okay, what is the representation of z into or multiplied by r to the k in base R? What is the representation of this number in base R? Okay, so let's assume that the representation of z in base R is this number here, okay, which is d sub n minus 1, d sub n minus 2, all the way to d sub 1, d sub 0 in base R. Okay, our objective is to find a z times r to the k in base R. So who can suggest something to do here? What is the right conversion algorithm here? So we are converting from, we're assuming that this is decimal, and we would like to convert to R. So the right conversion algorithm is decimal to base R, which means integer decimal to base R, which means successive divisions and collecting remainders, right? So this is the number, which is z times r to the k. And if you divide this, so we have z times r to the k, and then we divide this by r, remember? And then collect the remainder and the quotient. What is the quotient here? The quotient, which is the result of the division, okay, is going to be r cancels with 1 power of z. So z times r to the k minus 1, right? This is the quotient. What is the remainder?
0.
0. Why? Because this number is divisible by r, okay? It's divisible by r. It's basically multiplied by r to the k, right? So this is what I did. So you have z times r to the k, and if you divide it by r, you get z times r to the k minus 1, right? With a remainder of 0. And then you take this number and put it here and divide it by r. You get z times r to the k minus 2 with a remainder of 0. We are assuming that k is greater than 2 here, okay? And the remainder is 0. And then all the way up to z times r to the k minus z times r to the power 1, okay? All right, and if you divide this by r, you get z itself, okay? Okay, which is what? Which is z times r to the 0 or r to the k minus k, right? Isn't it the same? Okay, so and the remainder will be 0 here, okay? So how many zeros do we have here? We have minus 1, minus 2, minus 3, minus 4, all the way to minus k. So we count from 1 to k. So we have k zeros, okay? And then we already know, actually, how to convert z to base r, okay? So starting from this line, we don't need the conversion here. Why? Because we already know what is z in base r, which is this. We are assuming that z is this, basically, okay? So basically you'll have these digits, okay, one after the other, okay, until you get d sub n minus 1. Okay, so, and then you collect the digits, okay, this way here. So you have z here, okay, followed by how many zeros? K zeros, okay? So in base r, z times k, r to the k is equal to z followed by k zeros. That's it, as simple as that. Okay, so we are just concatenating k zeros in front of z in base r. This is the representation in base r, okay? But it's not necessarily the same representation in decimal. Remember that, okay? So this makes sense, okay? Because in decimal, remember, in decimal, for example, if you have 192 times 10 to the 3 is equal to what? 192 followed by how many zeros? 3 zeros. What is the 10 here? What is the 10? It's R. It's our R. Well, our R is 10 here, which is the base. Okay, so we have 192, which is Z here, the same number, and then followed by 3 zeros, which is the power here, the K. Okay, so in any other base, okay, you'll have the same result. Okay, so let's see examples. So what is this number here? 1FA in hexadecimal multiplied by 16 to the 4 represented in hexadecimal. Okay, it's simple. That should be simple after explaining to you what we did. Okay, what we saw in the previous page. Okay, which means that I just need to put this number and follow it or succeed it by how many zeros? 4 zeros. Okay, this is the answer in hexadecimal. Okay, 1011 multiplied by 2 to the 2 is nothing but 1011 in binary, of course. 1011 in binary followed by 2 zeros. Okay, because we have the power 2 here. And we have times 2 to the power 2. Okay, it has to be the same radix as this one here. Okay, 7312 base 8 times 8 is nothing but 7312 followed by a 0 base 8. Okay, and this is a decimal example. So let me just give you a perspective of why we call this a left shift operation. Okay, so we have the number here, for example, 1011. Okay, and then we multiply it by 2 to the 2, like this case here, for example. Okay, if you multiply it by 2 to the 2, then this will be shifted to the left 2 places. Okay, so we have 1 0 1 1, and then we put, instead of the 1 1 here, okay, we put a 0 0. Okay, so this is similar to, so it's exactly shifting the number 2 positions to the left and putting zeros, okay, in front of the number that is equal to the shift amount. Okay, so this is, because of this, we call this a shift left operation. If you multiply by the base to the power k, then you're basically left shifting by r to the k. Okay, so this is a shift left operation. Do you see that, guys?
Yes, clear.
Okay, so what about dividing by r to the k? You can derive the same result by dividing by r to the k, and you'll realize that it is nothing but a shift right instead of shift left by k positions. Okay, so shift right is in case of division, and shift left is in case of multiplication by the base. Okay, here is some examples of shift right. So we have, for example, 10CB0, okay, in base 16 divided by 16. Okay, you just get 10CB. Okay, if you remember in decimal, I think we have a decimal case. Yeah, here in decimal, okay, we have 10900 in decimal. This number is when divided by 100, you just get rid of these two zeros in front of it. The answer will be 109, okay, in decimal, of course. And if you have the binary number 1011 followed by 3 zeros divided by 2 to the 2, then you'll get rid of 2 of these zeros, and the number will be 10110. The most important thing is that you need to make sure that you're dividing by the same base as given in the number. Okay? Otherwise, this won't work. Okay? Any question?
Here.
Okay, so shift left means multiplication by the base. Shift left by 1, for example, multiplication by r. And shift right by 1 is division by r. Okay? Okay, now we turn our attention to addition and subtraction of unsigned binary numbers. Okay? Now, addition is the easiest you can think of. Okay, it's exactly the same as the decimal addition. Let me make sure that you guys remember what we do in decimal in order to do that. Let me erase what's left over from the previous section. Okay. So let's say we have 125 plus 512. Okay. Let me put some higher number here. Let's say 8 here. Okay, 518. Okay. So if I say 5 plus 8, okay, so what do we do? Let's describe the algorithm. So do we add, for example, the 5 with the 1? No. We add the 5 with its similar position, 5 with the 8, okay? 5 with the 8, and if there is a carry, okay, the carry is moved and added with the next stage because it belongs to the next stage, okay? So 5 plus 8 is 13, right? So we have a 3 in the ones digit and a carry of 1, okay? Now the carry is going to be added with these two numbers, okay? So 2 plus 1 is 3 with a carry of 1, 4, okay? So you say 4 here, okay? And there is no carry in the next stage. Or there is a carry of 0 if you want, okay? So now 1 plus 1, 1 plus 5 is 6. Okay, the only thing that I wanted to illustrate here is that we are adding every digit with its corresponding digit from the other number. Okay, so it doesn't, it will not work if you, for example, say 1024 plus, let's say 64. Does it work if we do this 4, 2, 4, 7? Does it work? Is this the expected answer?
No.
No, you have to add every digit with its corresponding digit. So the right way to do it, so let me just put a big X on this, okay? And the right way to do it is 1024 plus 64. It's exactly at this. So the tens with the tens and the ones with the ones. Okay, so you say 8 and then 8 and then 0 and then 1. Okay, so this is important. The bit alignment, okay, position alignment is important. Okay, so what we need to do now is to understand what is the result in binary, okay, of adding 2 bits. Okay, so what are the possibilities of adding 2 bits? How many possibilities do we have? We have 4 possibilities basically. We can either add 0 plus 0 or 0 plus 1 or 1 plus 0 or 1 plus 1. Okay, now for the first 3 cases, answer is straightforward. Okay, the decimal answer is the same as the binary answer. It's 0, 1, 1. Okay, however, in the final case, 1 plus 1 is 2 in decimal. However, we need to convert this 2 to binary, okay, which is 1, 0 in this case. Okay, 1, 0. So we have a 0 with a carry of 1 to the next stage. Okay, you get it? We have a 0 with a carry of 1. All right, so in order to be consistent, we will put a 0 in front of every number here to indicate that the carry is 0 here. Okay, so in order to make things crystal clear, okay, we say this is the carry bit and this is the sum bit. Okay, so the sum is going to be 0 1 1 0 0 1 1 0 and the carries are going to be 0 0 0 1. Okay, for these combinations. Okay, you get it? So if I tell you what is 1 plus 0, you'll say, well, it's 1 with a carry of 0. If I tell you what is 1 plus 1, you say 0 with a carry of 1. Okay, you have to memorize this. Okay, but what if we have 1 plus 1, but we have a carry from the previous stage? So it becomes 1 plus 1 plus 1. What is the answer here?
It would be 1 and with carry of 1.
Excellent. So it is 3 in decimal, but 3 in decimal is converted to binary as 1 with a carry of 1. Okay? So 1 with a carry of 1. Let's see a trivial example here. Okay? So we are adding these two numbers in binary. So 1 plus 1 is going to be what?
0 with a carry 1.
So 0, the answer is going to be a 0, or the sum is going to be a 0, and the 1 is carried out to the next stage. Okay? And then we have 1 plus 0 plus the carry. Okay? 1 plus 0 plus the carry is going to be
0 and carry 1.
excellent. Yeah, 0 with a carry of 1. And then finally, 1 plus 1 plus 1 is
1 1.
1 with a carry of 1. So there is a carry of 1, and this carry comes down. So the answer is going to be 1 1 0 0. Okay, and the final carry is 1. Okay, so you can say, well, you can say that the answer is 1 0 0. Okay, and with a carry of 1. Okay. So it depends on the question. So if the question says, for example, indicate if there is a final carry, then you should say, well, this is the answer with the final carry. Okay, so this is an exam question. Okay, we would like to compute 0 1 1 1 1 1 1 1. Okay, and this underbar here is for readability. So we're just splitting the parts of the number into 2 parts so that we can read it easily. Okay, and we would like to add this plus, okay, 1 1 0 1 underscore 1 1 1 1. Okay, and indicate if there is a final carry or not. Okay, so let me bring this table up in the you know what, let me just copy it, paste it. All right, so this is going to be the column for, or the row for the carries, and first number, second number, and the sum. Okay, so let's copy the first number. It's going to be 0 1 1 1. It doesn't have, by the way, you don't have to do it this way. You don't have to draw a table in order to do the addition, but it makes your life easier if you do it. Okay. And then 1, 1, 1, 1, because you can align the bits more easily. And then the second number is going to be 1, 1, 0, 1, and then 1, 1, 1, 1. Okay. So now we do the addition. Okay. So I'm starting from here. Okay, we start from the least significant bit, of course, which is this one here. Okay, so 1 plus 1 is 0 with a carry of 1, right? And then
Yes.
1 plus 1 plus 1 is
1 with a carry 1.
excellent. 1 with a carry of 1. 1 plus 1 plus 1, again, 1 with a carry of 1. Boring, right? It's easy. 1 plus 1 plus 1 is 1 with a carry of 1. And then 1 plus 1 plus 1 is 1 with a carry of 1. Change now. 1 plus 1 plus 0 is
0 with a carry 1.
excellent. Okay, and then 1 with a carry of 1, and then 0 with a final carry of 1. So the answer to this question, okay, is that this is the sum, okay, and there is a final carry of 1, okay. But usually we write the carry as part of the answer, okay, for unsigned numbers. Okay, any question about this? This is it's as simple as that, by the way. It's very simple.
Yes,
The
why there
addition,
is the underscore on the question?
it's just for readability. Readability. I just want to separate the high 4 bits from the low 4 bits. Okay, you don't have to have it, by the way. You get it?
Yes, yes.
Okay. So let's move on. If there are no questions, let's move on to subtractions. Okay. So subtractions is also done using the same method of decimal. Okay. But we will do it in a more efficient way. So let me give you an example in decimal. Okay. And then we proceed to the binary case. Okay. So I would like to subtract 173 or 185 from 173. 173 minus 185. We expect the answer to be positive or negative here.
Negative.
Negative. But we are not going to do it the normal way. Okay. We're going to do it how the computers do it. Okay. So now in order to subtract 3 minus 5 doesn't work, right? So you have to borrow 1 from the next position. 1 from the next position means it's 10 with respect to the current position, right? So if I borrow 1 from here, I'll just record it here. I borrowed 1 from this column. This one will become what instead of 3? It will become 13, right? Isn't it?
Yeah.
Yeah. So 13 minus 5 is 8, right?
8.
Yeah. And then 7 minus 8, it doesn't work again. So we borrow
Have to
a
borrow.
1 from here. So this becomes what? 17. 17 minus 8 is what? Is 9, but we have a borrow already of 1, so it becomes 8, right? You get that?
16, not
Yeah, it's 17 minus the borrow minus 8, right?
Oh, yes.
Okay.
Yeah.
So it's 8. Answer is 8. Okay. So, and then finally we have 1 minus 1, which is what? 0, right? But we have a minus 1 here. So 0 minus 1 doesn't work, right? It doesn't work. So we have to borrow 1 from nowhere. So we have a borrow of 1 from this position here. So this becomes what? 11 instead of 1, right? We're assuming that this will work. So it's 11 minus 1, 11 minus 1 minus 1, right? Which is 9. And then we stop here because we don't have any more digits. However, you must understand that we have a borrow of 1, a final borrow of 1, which means if you have a borrow of more than 0, then your answer is negative. What is the position of this borrow? The position is in the 4th digit, okay? So it has a weight of 10 to the power 3, okay? So this one here is equivalent to 1,000, not just 1, okay? All right, so the final answer is 173 minus 185 is nothing but 988 with, let's say like this, a borrow of 1. Okay, and when you say with a borrow of 1, it means that the borrow is 1 followed by a number of zeros equal to the length of the answer, okay? 1000. Okay, this is the magnitude of the borrow. It's minus 1,000. So the answer in our for us as humans is going to be 988 minus 1,000. Okay, which is nothing but minus 12. Does it make sense? Actually, 173 minus 185 is minus 12. Exactly. Okay, so we are going to do the same trick in binary now. Okay, so in binary, which becomes much easier, by the way. Okay, so we have the difference corresponding to the sum in the addition and a borrow bit. Okay, so for the 4 cases here, we have 0 minus 0 is going to be, the difference is going to be a 0, and there is no borrow here, right? Let's skip this for now. Okay, 1 minus 0 is going to be a 1, okay, with a borrow of 0, right? It's 1 minus 0 is 1, simply. It's 1. The difference is 1, right? Okay, but the borrow is 0 as well. We're just taking record of the borrow because eventually we have to implement this in computers, right? We have to tell the computer whether the borrow is 0 or 1. Okay, and then 1 minus 1 is 0 with a borrow of 0, right? Now, the only case that is complicated is 0 minus 1, and in decimal it is corresponding to minus 1. Okay, however, in binary, okay, in binary, which is in which we have to split the difference and the borrow, okay, it means that we need to borrow 1 from the next stage. Okay, we have to borrow 1 from the next stage, and when we borrow 1 from the next stage, okay, what will x be? When you borrow 1, x is 0 now, and if you borrow 1 from the next stage, x will become what?
1 0. Yes.
2. Excellent. It's 2 in decimal. Yeah, it's 2. Why? Because now we are working in binary, because 1 in the next digit is actually 2 to the 1 with respect to the current position, right? So in decimal it was 10, now it is 2. Okay, it's basically the base in general. Okay, so 2, this becomes, instead of 0, it becomes 2. So now 2 minus 1 becomes, the difference is 1. So the answer is going to be 1 with a borrow of 1. Okay, that's as simple as that. Okay, so let me erase this now and do this simple example before we do the exam question. Okay, so now we would like to subtract these two numbers. 1 minus 1 is boring. This is boring. This is 0 with a borrow of 0. Okay, 0 minus 1 is 1 with a borrow of 1, right?
Yeah. Yes.
Okay, now 1 minus 1 is going to be what? A 0, right?
Zero.
0.
a 0, but there is a -1 here. So it becomes 0 minus 1. So the answer is going to be 1 with a borrow of 1. So the final answer is 101 minus 111 equals 110 with borrow of 1. Okay. Do not, please, when you write in the exam, make sure that you write full words. Do not just write short, because I'm speaking here, I don't have to write down the full word, okay? So this is with a borrow of 1, okay? So when there is a borrow, as I told you in the case of decimal, it means that the answer is what? Negative, right? So let's convert everything to decimal and check if things make sense or not. So this is 101, which is 5 in decimal, and this is 111, which is 7 in decimal. So 5 minus 7 is -2, right? So now the case, the negative part of the number makes sense,
6.
okay? And however, the number itself, is 6. Answer here. However, we have a borrow of 1, so 6. Okay, 6. Okay, so the answer here is 6. Okay, which is 1106 with a borrow of 1. What is the magnitude of the borrow? The magnitude of the borrow is minus 1 followed by how many zeros in binary?
3.
3 zeros. Excellent, because it's the size of the answer. Yeah. So 1 followed by 3 zeros is what in decimal?
8.
8. Excellent. So the answer is -2. They check, right? -2. It's exactly what we expect. Okay, you get that? Okay, let's do the exam question. It's done here. Okay. I didn't have time to erase it. Okay. Because actually, I have the class right before your class, and they were late, a little bit late. Okay. So now I'm going to copy this. Paste it here. All right. So our objective is to find the difference between these two numbers. So this minus this. Again, this is for the borrow first number, or yeah, A, and then minus B. Okay. And then there is the difference here. So the first number is 0, 0, 1, 1, 0, 1, 1, 0. Okay, and then 1, 1, 1, 0, and then 1, 1, 0, 1. Okay, now we do the subtraction. So 0 minus 1 is, remind me.
You have to borrow.
1 with the borrow of 1.
Excellent. 1 with a borrow of 1 to the next stage. And then 1 minus 0 is 1, but there is a minus 1 here. So the answer is going to be a 0, right? You get it? Okay, 1 minus 1 is 0, boring. Okay, 0 minus 1 is 1 with a borrow of 1. 1 minus 0, again, it's the same pattern here. You see 0, okay? So 1 minus 0, and then minus 1, it's going to be a 0. Okay, and then 1 minus 1 is going to be a 0. And then 0 minus 1 is 1 with a borrow of 1. Here, I want you to pay attention. This is something new here we haven't seen. Okay, so here, answer here, 0 minus 1 is going to be a 1 with a borrow of 1, right? But there is a minus 1 here. There is a minus 1. So the answer is not going to be a 1. It's going to be a 0 with a borrow of 1. Do you see that? Are you following, guys?
Yes.
Yes.
Okay, so this is the final one which we haven't seen so far. So 0 minus 1 is basically 1 with a power of 1. However, we subtract 1 from the ones digit, it becomes a 0. Okay, that's it. That's the material for today. Next time we will continue with hexadecimal addition, inshallah. So for just to summarize what we talked about today is shift left and shift right operations are basically realized by multiplying shift left multiplying by the base, and shift right is dividing by the base. And then we talked about addition and subtraction in binary as well as in decimal. Okay, I just showed you the algorithm in both binary and decimal. Okay, for addition and subtraction. Okay, any question? All right, let me just stop recording because otherwise lecture will be long. Unless you guys have a question, otherwise I'll stop it. Okay, let me stop it.